canceled event, we're going to publish an integration event that's going to kick off some downstream processes. I'm going to walk you through what's going to happen. And then we're going to transition into cancellation started. From this state, we can either go into payments refunded when the respective event is handled, or into tickets archived. From both of these states, we can go into the other respective state. So from payments refunded, we can go into tickets archived, and from tickets archived, we can go into payments refunded. Finally, when we handle both the event payments refunded and event tickets archived, we're going to publish our composite event, which is going to publish the event cancellation completed integration event and transition our saga into the final state, effectively completing our saga. Now let's take a look at what's going to happen when we publish the event cancellation started integration event. If I look for any handlers for this event, you will see that I have one in the ticketing module. So let's take a look at what we have inside. This is going to send the cancel event command inside of the ticketing module. If I go to the cancel event command handler in the ticketing module, you can see that we're just going to call the cancel method on this event instance, which is all executing inside of the ticketing module. And this is going to raise a respective domain event inside of that module that's going to then trigger some other behavior. So let me move over to the ticketing module to walk you through what's going to happen. I will open up the application layer, and then let's take a look at the cancel event use case where we have two domain event handlers. We have the archive tickets event canceled domain event handler, which is going to handle the respective domain event and is going to send the archive tickets for event command. We also have another domain event handler that's going to send the refund payments for event command. And as you can see, these domain event handlers are implementing the individual steps that are required to cancel a particular event. So they handle the archiving of any tickets and refunding the payments for a given event. If we take a look at the respective command handlers, let's say the refund payments for event command handler, you can see that it's going to fetch this event from the database, look for any respective payments, and then just call the refund method on each payment. This is going to trigger our respective domain event on each payment object, which is going to be individually handled inside of the respective domain event handlers. So just breaking down a bigger process into a series of smaller, more manageable steps. In a proper implementation, we would want to wait for all of the payments to be refunded before calling the payments refunded method on the event, which is going to trigger another domain event, and that event will be handled by the event payments refunded domain event handler, which is going to publish the event payments refunded integration event. And if we go back to our cancel event saga for a moment, you can see that we are handling the event payments refunded integration event. So this is how this integration event gets sent to our saga instance. It's published as a reaction to the event payments refunded domain event. The same applies for archiving of the tickets. So we have an archive tickets for event use case, which is going to eventually handle the event tickets archive domain event and publish a respective integration event, which is going to help us transition our saga into a new state. I will go back to my saga and close down all of these files because we're going to go back to them a bit later. And then let's consider how we are going to configure the actual cancel event saga with mass transit. If you recall from some of the previous lessons, but I'm going to do a brief reminder, we configure the respective consumers for the integration events of our modules using a static method defined on the respective module class. This method accepts an iRegistration configurator, which is how we register our consumers, and we can use the same approach to register our saga. So let's close this down for now. And let's go into the events module. I'm going to define a configure consumers method. So it's going to be a public static void method. Let's call it configure consumers. And it's going to accept an iRegistration configurator instance. And then what I can do is say registration configurator add saga state machine. And I need to specify my saga instance. So cancel event saga. And I also need to specify the respective state. So cancel event state. By default, sagas in mass transit are going to run using an in-memory repository that's going to persist the saga state. But I want to use an actual persistence mechanism, and mass transit supports a lot of options for this. You can use a SQL database, you can even use Redis, which is the option that I'm going to use. So let's go back to the common module, and I'm going to install a NuGet package inside of the Evently Common Infrastructure project. I'm going to look for mass transit, and you will be able to spot some persistence mechanisms. For example, here is mass transit Entity Framework Core that supports persistence using EF Core. I want to install the mass transit Redis persistence. So let me look for this NuGet package, and I'm going to install the latest version of this NuGet package. What this is going to allow me to do, if I go back to my events module class, is called the Redis repository method. And if you recall, I said that by default, we would be using the in-memory repository. So Redis is a slightly better option. Now, in order to tell mass transit how to connect to our Redis instance, this method accepts a connection string. And the problem is we don't have a way to pass in a connection string and still respect the method signature, which should be a void method accepting an iRegistration configurator. So how you can go around this is make this method return an action of iRegistration configurator. Then I'm going to update the method arguments to accept a Redis connection string. And what I'm going to do is make this return an action instance. So I will say return registration configurator, and then you can define the actual action that is going to configure the state machine and the Redis repository instance with the connection string specified. And now I can call this from my program file when I'm calling the add infrastructure method, and I can say events module configure consumers, and I need to pass in the Redis connection string, and this is going to return back an action that can be assigned to this collection. And this is how I'm going to wire up the state machine with mass transit from the events module. Finally, with all of this in place, the only thing remaining is for us to test our Saga. I'm going to start off our long-lived process for canceling an event by sending a delete request to the respective cancel event endpoint. Let's go ahead and send this request. We're going to land inside of the cancel event command handler, which is going to raise the respective domain event. And when we handle this domain event, we're going to publish an integration event that's going to start off the cancel event Saga. So I'm going to press continue, and we land back in Postman with our request completed. And after a few moments, when our background processor executes, we will land in the event canceled domain event handler. This is where we will publish the event canceled integration event, which is the event that starts off our Saga. Now I'm going to take the event ID that we have here, and I want to show you something using this value. If I open up my console and type in docker ps, we're going to get a list of containers that we currently have running. If I type in the command docker exec, and then I pass in the identifier of our Redis container, which is this one here, and then I say Redis CLI, we can go into the CLI of our local Redis instance. And from here, I can call the methods available in the Redis CLI. So I can say get and pass in a key value, and I'm going to use the identifier of our event as the key value that I sent to Redis. And you can see that we don't have anything under this value inside of our cache. Now let's go ahead and publish the event canceled integration event. So after the event has been published, I should be able to go back to my console and execute the same request, and you can see that it's still null. This is because the publishing of my event goes through an inbox. So we first have to wait a few moments for the inbox to process this integration event. So I will press continue from Visual Studio. As you can see, after a few moments, our integration event gets processed and it's published to the other modules in our system. Eventually, this is going to lead to executing of the cancel event command in the ticketing module. If we check the state of our Saga right now, you can see that we actually have a value present inside of Redis. This is because our initial integration event was processed, and you can see that the current state of our Saga instance is cancellation started. The value tracking the cancellation completed status is currently set to 0. Now if I go ahead and press continue and complete my command handler, we're going to have to wait a moment for the respective domain event to be handled, and you can see that this is going to trigger the archive tickets for event command, as well as the other command for refunding the payments for a particular event. So I'm going to execute both of these commands, and this is going to lead to the publishing of the integration events that are going to transition our Saga into the next state. So after our commands complete, you can see that we are handling the respective domain events, and now we are publishing the event tickets archived integration event. I'm going to place a breakpoint after we publish the integration event, and let's take a look at the current state of our Saga. So you can see that it's still inside of cancellation started because we didn't yet handle this integration event. So if I hit continue, we're going to land inside of the domain event handler for the event payments refunded domain event. So this is the second event that we want to handle, and this one is going to publish the event payments refunded integration event. However, if we check the state of our Saga, you can see that the current state is tickets archived. So now let's go ahead and publish the other event that we are waiting for, which is event payments refunded. And if I hit continue and this event gets sent, and we check the state of our Saga again, you can see that this time the current state of the Saga is final. This is because we have handled both of the events that transition our Saga into the final state. The composite event has been published and the Saga is transitioned into the final state. You can also see that the cancellation completed status has a value of 3. So this was a detailed demonstration of implementing a state machine Saga using mass transit, and I hope you enjoyed my explanation. We defined a relatively simple state machine with an initial and final state as well as 3 intermediate states and the events that take us from one state into the other. And then we use the mass transit state machine support to define the transition between our states by reacting to a particular event. As a reaction to these events, we could publish an integration event that could be handled by the other components in our system, as well as transition our Saga into the next state, which is going to lead to other side effects inside of our system. And this brings us to the end of the current lesson about implementing the Saga pattern and managing an orchestrated workflow inside of our application. We're also going to wrap up the current chapter about event-driven architecture, and inside of the next chapter, we will be talking about testing modular monoliths.